Yes, good afternoon to all. And today we are going to discuss about the biomolecules questions. Okay. So yesterday we have seen some questions, and today we are going to continue with it. Okay. Yes. And coming to the yes, good afternoon to all. Coming to the first question for today. So you can see the question on the screen. So given below are two statements. One is labeled as assertion, and another one is labeled as reason. And assertion is amylose is insoluble in water. And the reason is amylose is a long linear molecule with more than 200 glucose units. So these two are the assertion and reason given to you. You have to choose the correct answer from the given options below. Okay. So you can take few minutes and you can try for the answer. So let me discuss the answer with you. Amylose is insoluble in water. So actually it is wrong, right? So amylose is soluble in water. Amylose is soluble in water. And amylose is a linear chain molecule with more than 200 glucose units. That is correct. It has more than 200 glucose units only, but it is soluble in water. So what is the answer for this question? A is not correct, but R is correct. Okay. So option D is the answer for this question. So I'll move on to the next question. Which one given below is a non-reducing sugar? So glucose, sucrose, maltose and lactose is given to you. Glucose is a monosaccharide. Glucose is a monosaccharide. And sucrose, maltose and lactose. These three are disaccharides. Okay. But all monosaccharides and disaccharides are reducing sugar except sucrose. So sucrose is an exception, right? So there is no free aldehyde group or ketonic group present there in sucrose. So sucrose is an exception to this. So the correct answer would be the sucrose. Sucrose is an exception. It is a non-reducing sugar. Okay. So good afternoon, JND Bhavnagar. Good afternoon to you. Well, I've been discussing the second question, and next I'll go for the third question for today's class. You can see the structure of sucrose. It is made up of alpha D glucose and beta D fructose. There is one glycosidic linkage present there, and it is a non-reducing sugar. So since the aldehyde group and ketonic group, they are involved in the glycosidic bond formation, the aldehyde and ketone group cannot be reduced to alcohol or some other substance. Okay? So it is non-reducing in nature. The only non-reducing sugar is sucrose in disaccharides. Okay. And coming to the third question. In a protein molecule, various amino acids are linked together by. In protein molecule, the various amino acids are linked together by peptide, beta bond, alpha glycosidic and beta glycosidic. So what could be the correct answer for this question? It's very easy question, right? Protein molecule, the amino acids are linked together by peptide bond, right? So let me take an example for you. I will take glycine. So the glycine formula is CH2, COOH, NH2. Okay. And I'll take alanine as the other example. So alanine structure would be CH, CH3, NH2 and COO. So this is your alanine. Okay, this is alanine. So what I'm going to do? I'm going to remove the water molecule. So how to remove the water molecule? OH from acid and H from amine group. It will go out as H2. So and what we are getting at last? We are getting NH2, CH2, C double bond O, NH, CH, CH3 and COOH. So what we are getting, this is a protein. which is made up of 2 amino acids. And we are getting C double bond O NH group here. Okay. So this is called as amide linkage. Since this amide linkage is present in amino acid and it is forming a protein structure, it is called as peptide bond. This bond is called as peptide bond. So in protein molecule, the various amino acids are linked together by peptide bond. Got it? So option A is the correct answer. Okay. Yes. So now I'll go for question number 4. I'll go for question number 4. Which of the following hormones is produced under the condition of stress which stimulate glycogenesis in the liver of human beings? So which hormone is produced under stress? Thyroxine, insulin, adrenaline, and estradiol. So what is the answer for this? Bhavnagar students, can you try for it? Which hormone is produced under the condition of stress? Okay, the answer is adrenaline. It is a hormone which is produced under the condition of stress. So thyroxine is produced in the thyroid gland, which contains the iodinated derivative, and insulin is the hormone which is used for the blood glucose level in our body, and estradiol is a female secondary sex hormone. Okay, so our adrenaline is the one which is produced under the condition of stress. Got it? It is produced by the adrenal glands, and this powerful hormone is part of the human body's acute stress response. Okay, good. I'll go for question number 5. So the D plus glucose reacts with hydroxylamine and yields an oxime. The structure of the oxime would be. So what is the structure of glucose? So in glucose we have 6 carbons connected in a linear fashion, and in the first carbon we are having CHO aldehyde group, and to the second carbon OH will be at the right side and H is the left side, and for fourth carbon, fifth carbon also the same thing. The second carbon, fourth carbon and fifth carbon, they maintain the same representation, and for the third carbon alone you have to interchange, that is H on the right side and OH on the left side, and the last carbon will be occupied by CH2. Okay, so this is the structure of D plus glucose. This is the structure of D plus glucose. So this compound is now reacting with hydroxylamine. Formula for hydroxylamine is NH2OH. Okay, and it is yielding an oxime. So we have to find out the structure of oxime. So the oxygen from the aldehyde group removes out with the H2 of NH2OH as H2O. So H2O is removed and NOH is connected there. So C, H and the double bond NOH, and the remaining part is same. What is the remaining compound? So we have 6 carbons, right? So everywhere it remains same. So in all the position you will have the same. OH, H, and here OH and H, here OH and H, H and OH, and here CH2OH. Got it? So this compound is called as oxime. So it is present in which option? We have to look for the position of OH and H attached to the carbon. That is from carbon number 2 till carbon number 5. Okay. The other things you can see, the oxide part is remains same. Only the representation differs. So option D is the correct structure. The structure of oxime is option D. So you should know how to draw the structure of glucose. Then only you can answer for this question. Okay. Yes. So coming to question number 6. Match list 1 with list 2. Match list 1 with list 2. So glucose and HI is given. So when glucose reacts with hydrogen iodide, it forms 6 carbon containing alkane, which is hexane, right? It forms hexane. So A goes to 4. And when it reacts with bromine water is an oxidizing agent. So the system is getting oxidized to gluconic acid. Okay. And when it reacts with acetic anhydride, it forms glucose pentaacetate. And when it reacts with a strong oxidizing agent like HNO3, it forms saccharic acid. It forms saccharic acid. And D goes to 3. So what is the correct answer for this question? A4, B1, C2, and D3. Option A is the correct answer. Option A is the correct answer. So this is the structure of hexane. Okay. And gluconic acid is only one carbon. Aldehyde group will be converted to COOH. The remaining part, the remaining CHOH 4 times, they remain same. And at last CH2OH also will be there. This is gluconic acid. And glucose pentaacetate is CHO will be there. And here you will have CH, CH3, just will have the glucose molecule like this way. So this is CHO, and you will have CHOH 4 times, and this is your CH2O. So it is reacting with acetic anhydride. What is acetic anhydride? It is a reaction CH3COO, COCH3, right? And here the H from alcohol goes out with CH3COO as acetic acid. All the H will go out. Okay. So basically, what is the structure of glucose pentaacetate? It is CHO, C double bond O, CH3. How many times? 4 times. And CH2, O, CO, CH2. So 5 acetate groups are there. This is glucose pentaacetate, and the saccharic acid would be both the primary alcohol and aldehyde. Both will get oxidized. That is COOH, CHOH 4 times, and COOH. So this is your saccharic acid. This is your first compound, second compound, and this is your third compound, and this is your fourth. So these are the products you will get. Okay. So option A is the correct answer for this question. Now coming to question number 7. In DNA, the linkages between different nitrogenous bases are, in DNA, the linkages between different nitrogenous bases. Who are the nitrogenous bases in DNA? AT and GC, right? AT and GC. And here they'll form a bond. So what type of interaction is that? It is hydrogen bond. There is an hydrogen bonding interactions in the nitrogenous bases of DNA. Okay. And coming to question number 8, the sugar produced after complete hydrolysis of DNA is. So the DNA is actually deoxyribonucleic acid. It is a ribose sugar. Ribose sugar is made up of it is a pentose sugar. No, it is a 5 carbon containing system. So the complete hydrolysis will lead to a pentose sugar. Okay. So hexose is 6 carbon containing system, and the polysaccharide no, that we will not get, and disaccharide is also eliminated. So DNA contains ribose sugar, and since it contains 5 carbon, it will form a pentose sugar. Okay. And coming to question number 9, deficiency of vitamin B1 causes the disease. Deficiency of vitamin B1 cause beriberi. Deficiency of vitamin B1 cause beriberi. Okay. So beriberi is the, vitamin B1 deficiency. Vitamin B1 cause beriberi. Deficiency of vitamin B1 cause beriberi. Okay. So beriberi is the, vitamin B1 deficiency. Vitamin B1 cause beriberi. Okay. So beriberi is the, disease which is caused by vitamin B1. So it is a water-soluble vitamin. The sources are yeast, green leafy vegetable, milk and cereals. And the deficiency disease is beriberi. So this is the disease. Okay. It is caused by vitamin B1. Now, coming to the next question. Question number 10. Which of the following is not a fat-soluble vitamin? So there are two types of vitamins, right? Fat-soluble vitamin and water-soluble vitamin. So the fat-soluble vitamin, actually the fat-soluble vitamins are A, D, E and K. The remaining group, C group and B group, they are water-soluble vitamin, right? So from the given options, it is very clear that vitamin B complex is not a fat-soluble vitamin. So option A is the correct answer. Got it? Now moving on to question number 11. Moving on to question number 11. So this is a classification of vitamin which I was discussing with you. Fat-soluble vitamins are stored in liver and adipose tissue and they are readily excreted in the urine. Water-soluble vitamins and they cannot be stored. Examples are A, D, E, K for fat-soluble and vitamin C and B group falls in the water-soluble. Okay. Yes. So coming to the next question. Animal starch is the other name of. Animal starch is the other name of amylose, maltose. Amylose and amylopectin are the components of starch. So they cannot be the answer. And maltose is a disaccharide, right? So animal starch is the other name of glycogen. Is the other name of glycogen, which is a polysaccharide. Which is your polysaccharide. Glycogen is otherwise called as animal starch. Okay. Moving on to next question. Which of the statements about denaturation given below are correct? So you can see the three statements. Denaturation of proteins causes loss of secondary and tertiary structure. So that's that statement correct? Yes. So during the denaturation, primary structure remains same and secondary and tertiary structures, they are affected. Okay. And coming to the next statement, denaturation leads to the conversion of double strand of DNA. This is actually DNA. Okay. DNA into single strand. Yes. So bonds gets broken down and double strand becomes single strand. Okay. So second statement is also correct. Denaturation affects the primary structure which gets distorted. It will not affect the primary structure. Primary structure does not get affected. So option third statement is incorrect. So option 1 and 2, statements 1 and 2 are correct. So option C is the correct answer for this question. And C is the correct answer for this question. Okay. Yes. When the proteins are subjected to the action of heat, the water-soluble form of globular protein changes into water-insoluble fibrous, and this is called as denaturation. During this process, only secondary and tertiary structures are destroyed, but primary structures remain intact. Okay. So statement 1 and 2 are correct. So moving on to question number 13. Which of the following hormones contains iodine? Testosterone, adrenaline, thyroxine, and insulin. Testosterone, adrenaline, thyroxine, and insulin. It's very clear, no? Thyroxine is the one which contains iodine. Thyroxine is the answer. This is the structure of thyroxine. And you can see it is an iodinated derivative of an amino acid. Got it? Now coming to question number 14. Glycosidic linkage between C1 of alpha glucose and C2 of beta fructose is found in. So you should know the structure to find out the answer. So in which molecule we have alpha glucose and beta fructose as the component? Maltose, sucrose, lactose, and amylose. These are the structural information related questions. So the correct answer is sucrose. Correct answer is sucrose. It is the disaccharide which is formed from alpha D glucose and beta D fructose. C1 C2 linkage will be there in glucose only. In maltose and lactose, there will be C1 C4 linkage, and here also C1 C4 linkage. Only in sucrose we have C1 C2 linkage. In case of amylose, amylose is a component of starch. Amylose is a component of starch, right? It is a component of starch, which is a polysaccharide. So polysaccharide means more than 10 monosaccharide units will come. So the answer is sucrose. Fine. I'll go with the question number 15. In DNA, the complementary bases are DNA, the complementary bases are adenine and guanine, thymine and cytosine, uracil and adenine, cytosine and guanine, adenine and thymine, guanine and cytosine, adenine and thymine, guanine and uracil. So in DNA, the base pairs, who are the base pairs in DNA? Adenine and thymine, AT and GC. AT and GC, right? In case of RNA, it is AT and GU, guanine and uracil. Got it? So, who are the complementary bases here? Adenine and thymine, guanine and cytosine. So, you can see this answer in option C. So, option C is the correct answer for this question. Okay. Yes. Now, moving on to question number 16. L-isomer of tetrose gives positive Schiff's test and has 2 chiral carbons on acetylation, yet yields triacetate, and it also undergoes the following reaction. So we have to find out the compound X. So it has 2 chiral carbons. It can undergo acetylation and also yielding 3 acetate. If it is yielding 3 acetate, then the system should contain 3 OH group, right? And all the 4 options contains 3 OH group. And it gives positive result for Schiff's test. Schiff's test means that it is having aldehyde group in it, CHO group in it. So the answer lies between option 3, option C, or an option D. Okay, either one of those options could be the correct answer. It is undergoing the NABH4 reduction reaction, and also it is reacting with HNO. So what could be the compound, C or D? So it is giving positive result for Schiff's test, and it has 2 chiral carbons. So in both options you see, this is a meso compound, right? So if this is your X component, on reduction with NABH4, the CHO group will be converted to CH2OH. Now you can see there is a plane of symmetry. When you cut this molecule into 2, you will get 2 equal half, which is a meso compound and it is not chiral. Okay. So option D could be the correct answer, because if this is your compound X, this is your compound X, on reduction with NABH4, CHO will be converted to CH2OH. And since there is no plane of symmetry here, there are 2 chiral carbons, which are carbon number 2 and carbon number 3. And this is your compound B. And X also undergoes oxidation with HNO3. This is your reduction, and the HNO3 reaction is oxidation. And an oxidation, it forms A. Forms A, which is you get saccharic acid from this. Okay. So the correct option would be D. D is your correct answer, and I'll show you the reactions, complete reactions. So if D is given here for you, and it is reacting with HNO3 and undergoing oxidation, both aldehyde group and primary alcohol group will get oxidized. Okay, which is called as saccharic acid. This is called as saccharic acid. This is called as saccharic acid. And when the same compound reacts with undergoes acetylation, acetylation is reaction with acyl chloride, no? CH3COCl, it undergoes acetylation, and all the OH groups, they are replaced by acetate groups. They are replaced by acetate groups here. So triacetate is formed, and when it reacts with reducing agent, the CHO is getting converted to CH2OH, where there are two chiral segments. It undergoes positive test due to the presence of CHO group, and L is a tetrose. Since the compound X has 4 carbons, it is a tetrose. Option D would be the correct answer. Okay. Option D is the compound X. Now moving on to question number 17. The one that does not stabilize the secondary and tertiary structure of proteins is. So what could be the answer? The system which stabilizes the secondary structure is your hydrogen bond. And the system which stabilizes your tertiary structures, they are hydrogen bonding interaction and the sulfides linkage and van der Waals interaction and the electrostatic force of interaction. So these 4 forces stabilizes your tertiary structure. One does not stabilize. So all the options except option A falls under this. So option A, that is peroxide linkage, is not present in secondary or tertiary structure of proteins. All other 3, they are okay. A is the correct answer. And coming to question number 18. Match items of row 1 with those of row 2. So you can find 4 compounds to you on the screen and their names are given in row 2. We have to match. So the first is 2 compounds are having 6-membered ring and the remaining 2 is having 5-membered ring. Usually the 6-membered rings are called as pyranose. Since they resemble the pyran ring, they are pyranose, and the 5-membered rings are called as furanose, as they are representing the furan ring. Okay. Now, to calculate whether the compound is alpha or beta, you have to look for the OH group attached to the first carbon. So in all the cases, in the first 2 cases, this is your carbon number 1. And here, this is your carbon number 1, this is carbon number 2. Here, this is your carbon number 1, this is carbon 2. Okay. So in the first compound, you see OH lies at the bottom position. OH lies at the bottom position. Okay. So it is alpha. If OH lies in the bottom position, it is alpha. If OH is located on the top position, it is called as beta. So you could have get the answer by now. The first compound A is alpha D minus glucopyranose. This glucopyranose. Pyranose structure, you can find it in glucose, and furanose is present in fructose. Okay. So A is 3. And B is your beta D glucopyranose, which is 4. This is your 4th structure. And compound C is, what is compound C? It is OH is at the bottom position, so it is alpha. Here it is beta. So the name of the 3rd compound is alpha D fructofuranose, and 4th compound is beta D fructofuranose. So this is 1 and this is 2. Where you can find this option? Option A is the correct answer for this question. Okay. Yes. So coming to question number 19. During the denaturation of proteins, Which of these structures will remain intact? So just before few minutes we have discussed, only the primary structure remains intact. The secondary, tertiary, quaternary, all those structures will not remain intact. During denaturation, all the bonds, hydrogen bond, disulfide bond, van der Waals interaction, ionic interaction, everything will be broken down in secondary, tertiary, quaternary. Whereas in case of primary, since there are no interactions which are present there to stabilize the structure, it will remain intact. So option A is the correct answer for this question. Okay. So these are very easy questions which you will get from this lesson. And coming to question number 20, you have to match list 1 with list 2. So amino acids are given to you and the letter code is there. We have to match. So to answer this question, correct answer would be option D. That is for glutamic acid, the code is E. And for glutamine, it is Q. For tyrosine, Y. And for tryptophan, it is W. To answer this question, we don't have to remember concepts and all. Just you have to memorize this essential amino acids tabular column and non-essential amino acids tabular column. Okay. So here we have the list of amino acids and the letter code. Okay. You can take this essential amino acid tabular column as a screenshot, and these are the non-essential amino. And from this, you can match it. Okay. So we had what we had. We had glutamic acid, glutamine, tyrosine, and tryptophan. So glutamic acid is a non-essential amino acid, and the one letter code is E. And glutamine also you see, glutamic acid is given, glutamine is Q. Tyrosine is also a non-essential amino acid which has the formula Y. And the tryptophan is the only essential amino acid given to us. So the letter code for it is W. The letter code for tryptophan is W. So the first 3 acids are non-essential amino acids and the tryptophan is an essential amino acid. Just learn the acid and its code. Okay, just we have to memorize here. Let me go for the last question for today's session. So given below are 2 statements, assertion and reason. We have to find the correct answer. The assertion is alpha halo carboxylic acid on reaction with dilute NH3 gives a good yield of alpha amino carboxylic acid, whereas the yield of amines is very low when prepared from alkyl halides. Amino acids exist in bitter ion form in aqueous medium. So what is the correct? So who is the alpha halo carboxylic acid? Alpha halo, if I am having CH3, CH and a Cl or CO, this is called as alpha halo carboxylic acid. Okay. So here, when this particular compound reacts with dilute NH, when it reacts with dilute NH3, it gives a good yield of alpha amino carboxylic acid. So here HCl is getting removed. So the removal of HCl leads to an alpha amino acid. This is your alpha amino acid. Okay. And this amino acid exists in bitter ionic form. What is bitter ionic? The lone pair which is present on the nitrogen will go and attack the acidic hydrogen of carboxylic acid. The electrons between OH are shifted to oxygen. So this particular structure will be in equilibrium with the other structure, and the other structure is to you on the screen. This NH3 plus and we get COO minus. So since this particular structure has both positive and negative charges in it, it is called as Zwitter ion. It is called as Zwitter ion. And I already told you Zwitter ions are neutral. Zwitter ions are amphoteric. They react with acid as well as base. Since they contain equal number of positive and negative charges, they are neutral in nature. Okay, so in aqueous medium, amino acids form as Zwitter ion. The alpha halo carboxylic acids are the amino acids. Okay. So when you prepare amines from alkyl halide, the yield will be very low. But if you prepare an amine from amino acid from this particular alpha halo amino acid, the yield is very high. So both A and R are correct, and R is the correct explanation of A. So this is the solution given to you, the thing which I have already discussed. Okay. So both A and R are correct, and R is the correct explanation of A. Option D is the correct answer for this question. Okay. Got it? So with this, all the questions are got over for today's session. So thank you all for listening and watching this video. And I'll meet you all with the next lesson, with a new lesson, the next class. Okay. Thank you, students. Thank you, everyone.